with inverse trig. That means the integral of 1 over the square root of a squared minus x squared is arc sine x on A.
I see.
Exactly what we had before, but in reverse. And likewise, if there's a negative sign, how am I going to choose between these? Because I can just take the negative sign out the front, right? And the answer is it doesn't matter. Why not? Because you remember those graphs, right? Arc sine, oh come on. Arc sine is this, and arc cos is this. They're the same shape. They've just got a negative sign in the way.
Let's move up a bit.
And moving up will be taken care of by this constant. So it doesn't matter, you can pick either. So sometimes for some of the questions ahead, you might have chosen this one, but the book chose that one. And you'll have a different constant. Different sign, different constant, but otherwise the same. Doesn't matter. Let's try some. I think this pen does need more ink. Let's try some. Two doesn't fit in my pattern. That's okay. It's just a constant out the front. I've got a positive, so I'm going to use arc sine. What's my A here? Anybody?
Root 3.
Root 3. Because 3 is A squared. And there's my integral.
Would C be 0 because arc sine?
We don't know what C is. C depends on the real world context we come from.
Okay.
Yeah, we don't know. We always just go plus C. If it gives me limits, I don't need the plus C. We'll come to some of those soon. If it gives me a situation and the value is 7 when x is 2, then we can plug something in. Okay, this one is sometimes you have to play with it a little bit before you can actually do it. This doesn't quite look like this. I do have a negative sign. Again, you have a choice. You can take negative 5 out the front, or you can take 5 out and leave the negative sign. That's your choice. I'm going to leave the negative sign in so you can see an arc cos 1. But we still have a problem. I need this to be something squared minus x squared. So I'm going to factorise in a way that gives me minus x squared. So square root of 9 times something minus x squared. I had 1, so I need 9 times 1/9. Make sense? You want to factorise so that you have x squared here to match the pattern. So I want x squared, take the factor of 9 out, and then whatever goes here has to result in 1. 9 times 1/9 will give me 1.
What happens to the factor of 9?
So, this is a constant now, right? I took the root 9 as 3, and I took it out on the bottom. Now I can apply my pattern. 5 on 3, arc cos x over 1/3 plus constant. That was what confused you last time. Does that make sense now? Still looking a little bit lost? It's x on a, but a is a third.
Yep.
Dividing by a third is the same as timesing by 3.
Yeah.
If you want, you can write one more level in, one more step. X over brackets 1/3. Next line, 3x. So even when it doesn't quite look like the right pattern, factorise so it does. That's just a constant, take it out. Don't forget to square root it. Apply the pattern. What else have we got? What have we got? Okay. So this one's a tan, but be careful, this pattern has an A on the top. If this is A squared, I need a 3 on the top.
Do you take out 1/3?
Uh-huh. Because I'm multiplied by 3 here, I have to divide by 3. Now I match the pattern exactly. X on 3 plus constant. So it's just a bit of algebra, manipulate it until it looks exactly like one of these patterns. And you will get better and quicker at it with practice.